Hello to all my viewers. Today I am going to discuss about a very important concept that is known as central limit theorem in statistics. So what is central limit theorem? Central limit theorem is a very powerful tool because it allows statisticians to make accurate predictions about a massive population simply by looking at the averages of a few random samples. What do we mean by this? This means, for an instance, you want to know the average height of all adults. Adult means people above the age of 18 in a particular city, say in X city. So, you want to know what is the average height of adults in X city. Now, you cannot measure the height of all the people or the entire population in the city. So, you end up taking some samples. The sample should be of sufficient size. By sufficient size in statistics, we mean at least the sample size should be 30 in number. At least 30. Now, once you gather 30 people and measure their height, you add all the heights and take its average by dividing it by 30, you get something which is known as sample mean, right? So once you have taken in the height of 30 people, you divide it by 30, that is how you take the average, right? Average of the height. So height of 30 people. You take the average and this is known as sample mean. Now, central limit theorem suggests that if you again take a sample of 30 people, again take a sample of 30 people and keep on taking random samples of 30 people many times and calculate their mean, which is the sample mean, and you plot it. Plot the sample means, not the original data. This is very important to understand. Sometimes people confuse it with the original data. So central limit theorem does not talk about original data plotting. It talks about sample means. So once you have all the sample means and you plot it, you will get something which looks like a bell-shaped curve. So this bell-shaped curve is normally distributed curve. Normally distributed curve, also known as Gaussian curve, right? Or bell-shaped curve. Now, this bell-shaped curve tells you that your population, irrespective of whatever skewness is present in the population, once you collect random samples and keep on repeating the process again and again, and then plot the sample means, you will get a graph which is bell shaped, and hence you can apply parametric statistics on normal data. And this normally distributed curve tends to become more and more normal in nature, more and more symmetrical and uniform in nature as you increase the number of samples, as you increase the repetitions of taking the samples from the population and then taking their sample means, as I told you, and plotting it to get this bell-shaped curve. I hope this makes the concept quite clear. I hope the session was quite interesting and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more important and informative content. Thanks a lot.